Alright students, let's get to it. So classifying triangles as right, obtuse, or acute, we're going to be using the Pythagorean theorem. We take the two short sides, square them, and then we compare to our long side. If we've got a long side that's bigger than the squares of my two short sides, acute, or obtuse rather, because the big side's real big. If it's equal, of course it's going to be a right triangle. And if those two small sides are bigger, it's going to be acute because that big side is not big enough to overpower. So let's go in. Number one, you should be able to identify that as Pythagorean triple, 25, 144, and 169. On this one, we'll get 8 plus 16. We're going to compare that to 36. 36 is bigger, so this is going to be obtuse because our largest side is a lot bigger than our two smaller sides. Right here, we've got 400, 441. Trusty calculator tells me this is going to be 784. So you'll notice we got like 800 right here. And that's going to be an acute triangle because my two small sides are going to overpower that large side. Number 4, you'll notice we have another Pythagorean triple. This is just 5 times 3, 12 times 3, and 39 times 3. It's going to be another right triangle. I've got, is that going to be 13, 10, and then 144? 13, 100, and 144. This is going to be obtuse for number 5. And then here, I've got 196, 48 squared is going to be 2,304, and then that's going to be 2,500. Is this going to be right? Yeah, this is a 724, 25. Wow. Anyway, that's going to be another right triangle. It's a 7, 24, 25, and they've doubled it. So another Pythagorean triple. This one, we're going to solve for that unknown side length and then determine whether or not it's Pythagorean triple. Basically, all the numbers are whole. That makes it a Pythagorean triple. So we have 7, 19. So we'll do squared. We got 19, which is square root of 19 squared, minus 7, and that's going to be equal to x squared. So we get 12 is equal to x squared. So this is going to be 2 square roots of 3. It is not a Pythagorean triple. This one, 12, 13, just like we did up here, this last side will be 5. And it is a Pythagorean triple, that's a yes. 6 squared plus 5 squared is going to be 61. So x squared is going to be 61. X is going to be the square root of 61. This is no. 6 and 15. So I've got 225 rather. Minus 36, we'll take care of that. 225 minus 36 is going to give us 189. We want the square root of 189 for number 12. So it looks like it's divisible by 9. That'll give me, square root of 9 is 3, and then I'm left over with a 21. This is not a Pythagorean triple. I've got a square. These are both going to be 45, 45. Using that ratio, I've got 8 square roots of 2. These sides will both be 8. And even though this is a pattern, it's not a triple. Alright, so it is a pattern, but it's not a triple. We don't have perfect numbers on our sides. And for my last one, notice again, this is a 5, this is a 12. 5 times 2, 12 times 2. So this last one will be 13 times 2. And this one is a Pythagorean triple. Alright, moving right along. We have finding the areas of our figures. I've got, want this other side right here. I'll have 100 minus 49 will give me 51. So the square root of 51 is going to be this side. It's divisible by 3, 51 over 3. It's not divisible by 9, so I mean that's not going to break down. So I'm going to use this as my base, this is my height, and so base times height over 2. I'll have 7 square roots of 51 over 2 will be the area of that triangle. And you can it'll be feet squared. You can take and make that 3.5 if you want to. I'm going to leave it as that total fraction. I've got 4 and 12. So this last side right here, I need that height. You could actually do Heron's formula if you wanted to, because this will also be 12. This will be 8. But I'm going to do base times height because I like it better. I'll have 144 minus 16 will give me that side. So 144 minus 16 it gives me 128 take the square root of 128. This will be 8 square roots of 2. So I have 8 square roots of 2 here for my height. And I'm just going to do again base times height over 2. So my base is 8. My height is 8 square roots of 2. I'm going to divide that by 2. And I will get 32 square roots of 2. Notice I don't have any decimals. That'll be centimeters squared. I don't have any decimals here because they want it in most exact form, so I've got to leave it as a radical. This next shape, I'm going to cut it into pieces. If you know the formula for a trapezoid, you can do that. But I'm just going to cut it up into pieces. This rectangle right here is going to be 11 times 14, and then this is going to be a 9 by 14 triangle. So I'll have 14 times 9 over 2, which will be 7 times 9, 63. And then I've got 11 times 14, which will be 154. And then 7, 1, 2, 217. And that'll be square inches. That'll be the total. Oh, there we go. So 63 square inches for my triangle, 154 square inches for my rectangle, so 217 total square inches for the shape. Looking at number 31, I'm going to take and, well, how do I want to do this? This is 26, this is 62, so I have 38 left over for these two sides. Or is that going to be, that's going to be 36, my bad. That's going to be 36 left over for these two sides. So each side is going to be 18. I've got 18 and 30. This is 3 times 6. This is 5 times 6. So this, using my Pythagorean triple, should be 4 times 6. And you can do Pythagorean theorem to get that 24. However you want to get it, it's going to be 24. And then I'm going to take this side, I'm going to swing it over here and make a rectangle with it. Alright, so I will have a 26 plus 18 up top for my length and on the base. So that'll be 44. So 44 is my length. 24 I already found to be my width. So 24 times 44 will give me 1,056 for number 31. And that'll be meters squared. Alright, moving along. So on this one, I've got a box. It's 3 by 4. You'll notice they've got a lot of triangles in there. Drop this down and make a 90. Can you do that? I don't know. Yeah, it's listed. Is that on the paper? That's on the paper. All right, I was just checking. I thought that was a pencil line that someone drew in. Anyway, this is 4. So I'm going to take out this box right here. It's 12. This is 4 and 10. And I don't need to find the hypotenuse. So I've got a rectangle that's got an area of 12. I've got a triangle that's got an area of 4 times 10 over 2. So 12 plus 20. This is going to be 32 inches squared. Again, try not to make anything crazy. There are ways to make that problem harder. There is no need to. On this one, I've got 16, 20. This little side right here is going to be 12. 5 times 4, 4 times 4, 3 times 4. And I'm going to slide both of these triangles down to make a rectangle, and it will be 12 tall, and 16 plus 10, it'll be 26 across. So 12 times 26 is 312, and that'll be feet squared. Now there's so many different ways to set that up, and you may have a different way. Just make sure that it's accurate. This one, find the value of x. I have a 12 side. This is going to be my isosceles right triangle. That'll make this one the square root of 2 sides. So 1 times square, 12 times 1, 12 times square root of 2. I've got 8, so these are going to be 4 square roots of 2. And you'll notice, if this is a 1 side, I multiply by the square root of 1 times 4 square roots of 2. It's 4 square roots of 2. And then the square root of 2 times 4 square roots of 2 will give you 8. So this is 1 times the 4 square roots of 2 right here and here. And this is going to be square root of 2 times 4 square roots of 2 to get that last side. On this one, these two match. So these two will match. This is 5 times the square root of 2. So this will be 1 times 5. 5 times the square root of 2, 1 times 5. 5 for x. Alright, we'll cut the video.